When you eat a cherry, what do you throw away? The stem, the pit, maybe even the flowers still on the tree. But what if the juicy flesh is actually the least concentrated part of the cherry? Scientists studying the sweet cherry tree, Prunus avium, have found that nearly every part of it, from the blossoms to the bark, is loaded with compounds being studied for their antioxidant, anti-inflammatory, antimicrobial, and metabolic benefits. Today we're going part by part through the entire cherry tree, the fruit, the peel, the stem, the leaves, the pit, the wood, and even the flowers and resin. And along the way, you'll learn exactly which parts you should never put in your mouth. Let's start with the part everyone already knows. Sweet cherries are far more than a sweet summer snack. Inside every cherry is a dense mix of polyphenol. The headliners are anthocyanins, the pigments that give cherries their deep red color, mainly cyanidin-3-rutinoside and cyanidin-3-glucoside, sometimes making up more than 70% of the fruit's total phenolic content. Alongside them, chlorogenic acid, ferulic acid, gallic acid, quercetin, camphorol, catechins, vitamin C, carotenoids, potassium, and a handful of organic acids like malic acid. Together, these compounds neutralize free radicals generated by everyday metabolism, pollution, UV exposure, and chronic inflammation, and lab studies consistently back up that antioxidant punch. But cherries aren't just about mopping up free radicals. Their polyphenol also appear to block alpha-glucosidase, an enzyme that breaks carbs down into glucose, meaning they may blunt how fast sugar hits your bloodstream after a meal. Human trials have picked up on improvements in oxidative stress markers, blood pressure, and blood lipids in people who regularly eat cherries. And that's just the part everyone eats. The next layer packs an even bigger punch. If your instinct is to peel your fruit before eating it, don't do that with cherries. The skin contains a much higher concentration of health-promoting phytochemicals than the flesh beneath it. Studies have found that cherry skins can contain several times more phenolic compounds than the flesh, with exceptionally high concentrations when measured on a dry weight basis. It's also where most of the anthocyanins are concentrated, with cyanidin-3-rutinoside being the dominant pigment responsible for the deep red color. These compounds do more than make cherries look appealing. In the fruit, they help protect against sunlight, pathogens, and other environmental stresses. In our diet, they contribute antioxidant and anti-inflammatory activity that researchers associate with many of cherries' potential health benefits. Ironically, the thinnest part of the cherry may be one of its most nutrient-dense. But the biggest surprise isn't the skin. It's the part most people twist off and throw away without a second thought. Herbal medicine has used cherry stem tea for centuries as a natural diuretic. Modern chemistry is finally catching up. Researchers have identified upwards of 26 distinct phenolic compounds in cherry stems: catechin, epicatechin, quercetin, camphorol, picoumaric acid, saponins, and carotenoids among them. If you're keeping track, that's a dozen-plus compounds, but the point isn't to memorize the list. It's that this waste is a genuine chemical powerhouse. Extracts made from stems show strong antioxidant capacity alongside antimicrobial and anti-inflammatory activity in lab testing, and yes, the mild diuretic effect that traditional medicine has claimed for generations has held up under scientific scrutiny. One practical note if you want to try this yourself: while the science backs up the traditional benefits of stem tea, try to source your cherries from organic or pesticide-free growers. You're brewing the part of the plant that's most exposed to agricultural sprays, so it's worth being a bit more selective here than you would be with the fruit itself. It's a good reminder that waste is often just a resource nobody's gotten around to studying yet. But if the stem impressed you, wait until you hear about the leaves. Cherry leaves are dense with phenolic compounds and show strong antioxidant activity in laboratory testing. Researchers are eyeing them for potential use in foods, cosmetics, and nutraceuticals. Same story as the stems. Don't worry about memorizing which compound does what. Just notice how consistently this tree keeps over-delivering. But here's the warning label. Young cherry leaves naturally contain cyanogenic compounds like prunusin. When those compounds are crushed or digested, they can release cyanide. The concentration tends to drop as the leaves mature, but that's exactly why fresh cherry leaves are not something to casually chew on or brew into tea at home. Natural doesn't automatically mean harmless. Plants make defensive chemicals for their own survival, and that biology deserves respect. Which brings us to the part of the cherry with the highest stakes of all. Everyone knows, don't swallow the pit. But here's why. The kernel hidden inside contains amygdalin and prunicin, cyanogenic compounds that release cyanide when crushed and digested. That's a hard no. What scientists are interested in is the oil pressed from that kernel. The kernel is roughly 25 to 30% oil by weight, and it's rich in oleic acid, linoleic acid, gamma-tocopherol, a form of vitamin E, and beta-sitosterol, a plant sterol linked to reduced cholesterol absorption. To be clear, though, that oil requires industrial processing to safely remove the toxins first. This isn't a home project. Please don't try to crack and press your own cherry pits. That oil is already being explored for cosmetic, nutritional, and pharmaceutical use, proof that something you'd never eat directly can still be valuable once properly processed. Just when you think researchers have covered every part of the tree, they went further. They studied the wood. Even the wood of the cherry tree is rich in beneficial compounds. Studies have shown that extracts made by boiling debarked cherry wood chips contain abundant polyphenol and exhibit strong antioxidant activity. In fact, researchers have explored cherry wood as a potential source of natural antioxidants that could one day complement, or even partially replace, synthetic preservatives in foods. The exact numbers are less important than the overall pattern. From the bark and wood to the leaves, stems, and fruit, nearly every part of the cherry tree is packed with bioactive compounds. It is remarkably difficult to find a truly waste part of this tree. And the tree still isn't done surprising us. Two parts almost nobody talks about, the blossoms and the sap. Cherry blossoms are loaded with flavonoids, phenolic acids, anthocyanins, and coumarins. In cell studies, blossom extract reduced inflammatory markers and protected skin cells from UV-related damage, and a small human skincare trial found it calmed skin irritation. That's why you'll increasingly see cherry blossom extract showing up in skincare formulas rather than supplements. The evidence is strongest for topical use, not swallowing it as a cure-all. Cherry resin, the sap that oozes from the trunk, is a mix of polysaccharides, phenolics, and terpenoid compounds. It's being studied mainly for injury care and skin support. Related tree resins have shown antimicrobial activity and support for tissue healing. Neither is something you'd casually consume, but both are more evidence that this tree wastes almost nothing. Across dozens of lab studies, animal experiments, human trials, and reviews, one message keeps repeating: sweet cherries are one of nature's richest sources of beneficial polyphenol. Antioxidant activity, anti-inflammatory effects, antimicrobial properties, blood sugar-related enzyme inhibition, cardiovascular support, and promising early anti-cancer signals in the lab. It's all there in the literature. But it's worth saying clearly, a lab finding is not a medical treatment. Eating cherries won't cure disease. What it will do is give your body hundreds of natural compounds working together in ways science is still mapping out. We often judge a plant by the part we eat, but biology rarely works that way. In the cherry tree, nearly every part has a role, and many are only beginning to be understood. Nature rarely wastes anything. Maybe it's time we stopped doing the wasting for it. If you enjoyed this exploration, like the video, subscribe, and share it with a fellow curious mind. Until next time, stay curious and stay healthy.